Hi guys, it's Mrs. Moss here, and we're going to continue our discussion about the moon and talk about the different circumstances that occur on Earth due to the moon's presence. We're going to start with tides, and tides are the daily changes in the rise and fall of the ocean levels, and it is a cyclic event. It occurs in a repeated pattern every day. The cause of the tides are due to the gravitational attraction between the Earth, the Sun, and the Moon. Tides are caused mainly by the gravitational attraction of the Moon. It's smaller than the Sun, but it is 400 times closer, so its gravity acts upon us. Now, look at this, and it is a picture of the high tide coming up and the low tide going out. And you can see how high these tide levels, the ocean levels reach, and how low they go as well. If you look at that boat, in high tide it sits up high on the water, low tide it's beached. And this happens every 6 hours. This is another picture of what can happen from the top to the bottom picture on the left. We have an area that is basically a beach at 10:25 a.m. By 1:30, that beach has started to fill in a little bit and is a little more water present. And by 4 p.m., it's completely underwater. And that's what happens with our tides. It comes in and fills up an area and it goes back out. Now you see on the right, they have the picture of the higher tide at the top and the low tide at the bottom. Again, that high tide brings the boat up and allows it to sit on the water just perfectly fine. But in low tide, that boat gets beached. So let's talk about this. Tides occur when the thin layer of water, and let's just finish getting these arrows. The thin layer of water, which we know as the hydrosphere, is pulled away slightly from the Earth due to the moon's gravity. Now, the gravitational attraction pulls water towards the moon and it creates a tidal bulge. The solid part of the Earth is pulled away from the ocean, creating another tidal bulge on the opposite side. So this picture demonstrates that with the blue shaded area being the water, the hydrosphere. And you can see how in some locations of the Earth at high tide, the water actually gets pulled away, whereas low tide, it gets brought a little closer. High tide occurs where the tidal bulges are located, and the Earth rotates through a high tide and a low tide twice a day. The time difference between high tide and high tide is approximately 12 hours apart, which means the difference between a high tide and a low tide is 6 hours. And here's a picture of something that occurs when the moon and the sun and the Earth are in perfect alignment. When they're in this phase, the sun and the moon are aligned, they pull in a straight line, and the gravitational attraction becomes very strong. We call this a spring tide. It occurs at a new moon and a full moon phase, and it produces the largest tidal ranges. Now, when we talk about tidal ranges, we're talking about the high tide is at its highest point, and the low tide is at its lowest point. So it is a very big difference between high and low tides. This is called a spring tide. Neap tides are opposite. In a neap tide, the moon and the sun pull in different directions. The gravitational force is much weaker, and it produces a smaller tidal range. Now that means the high tide does not get very high, and the low tide does not get very low. So there's a very small difference in the tidal levels during a neap tide. And if you look and see the way the sun, the earth, and the moon are aligned in this picture, it's in the first quarter and last quarter phases. So here we have our earth, and here we have the moon. So we have the earth, the moon, creating more of a perpendicular relationship as opposed to something that was just horizontal and lined up. So here we have pictures of both the spring tide in the top portion where the sun, the moon, and the earth are aligned. And again, it can happen in a new moon phase or a full moon phase. that's the spring tide, where the gravitational attraction is the strongest, really pulling at the tides. But if you look at the lower portion of this diagram, here we have the neap tide, and that is when the moon is in the third quarter phase or the first quarter phase. So the gravitational attraction has been broken and is much weaker. Now there's something else that occurs because of the moon revolving around the earth, and that's called an eclipse. Now there are two types of eclipses. Eclipses, we have the solar eclipse, when the sun is blocked out, and a lunar eclipse, when the moon is blocked out. And this is pretty easy to remember. If you can remember that an ellipse means to block out. Solar is sun, so sun blocked out. Lunar is moon, so the moon is blocked out. And let's look at each of those carefully. In a solar eclipse, the sun is blocked out. Now this occurs when the moon revolves between the earth and the sun, and the moon's shadow is then cast upon the earth. So if you look at this diagram, we have the sun, we have the moon, and we have the earth. And you can see that the moon is blocking the sun's light, casting a shadow onto this location on the earth. Now, not every location on the earth will witness this solar eclipse. It's only the location on earth that's directly underneath or in line with the moon. This is a picture of a solar eclipse taken from space, so you really can see the shadow that's being cast from the moon onto the earth. Here's a picture of a solar eclipse from the earth looking up, and what you see, the moon has perfectly blocked the sun, and it creates this larger glowing light behind it. This is a total solar eclipse. So again, it's when the moon travels between the earth and the sun, and the moon's shadow touches the earth. Just another diagram. If you're standing, where's my cursor? Here we go. If you're standing in this location on Earth, you will view this, a total eclipse. I want you to draw a diagram of the Earth, the Sun, and the Moon in your notes during a solar eclipse. Please make sure you have the relative sizes. So the Sun should be the largest, the Moon the smallest, and the Earth a medium size. And make sure you use your pencil or pen to cast the shadow onto the Earth, so that we get a full idea of what a solar eclipse is. Okay? Hit pause if you need to, but I'm going to continue on with lunar eclipses. Now, lunar eclipse is when the moon, lunar, is blocked. So how does this occur? Well, it occurs in the full moon stage, and it is when the moon revolves into the Earth's shadow. And again, it only occurs in the full moon stage. So let's take a look at this diagram a little more closely and see what's happening here. Well, we have our sun, and in this full moon phase, this is when we see, if we're standing here, we would look up and we would see the moon. But what happens at times is, because of the alignment can be so perfect, the moon revolves around the earth and goes into the shadow of the earth that's cast by the sun. So it's pretty interesting. Lunar eclipse, again, earth passes directly between the sun and the moon. So if you actually are standing right here and you're looking up at the moon, what you would notice is a reddish tint. The moon would almost look like it's darkening and turning a little bit red, and then it passes through that shadow and turning its regular bright color. So again, we're going to draw a diagram of what this looks like. Be sure you have the relative sizes. Again, the moon is the smallest, the earth is the middle, and the sun is the largest. And make sure you get the shadows that are being cast from the earth onto the moon. It's very important to draw this moon inside the earth's shadow. So why don't we observe eclipses every month? We always have full moon and new moon phases every month. Well, this doesn't always occur because the moon is orbiting us at a tilt of 5 degrees. So even though we can see a full moon and a new moon once a month, sometimes twice on a blue moon, but it doesn't always align with the sun perfectly to cast the shadow or to block out the sun or the moon and to create an ellipse. So because of the moon's tilt, we don't always see the eclipses. And in fact, they are considered to be rare. So let's make sure we get this information down in our notes. Make sure you've drawn your diagrams. And we're going to say goodbye to our moon. And I hope you can have a great day. We'll see you next time.